So use the following information for questions 1 to 3. So that's really important that we're checking that we can use any of this information in those first 3 questions. And it said the times between successive nerve impulses in milliseconds were recorded, and the mean, and the table below shows the mean and the 5-number summary for 800 data entries. Okay, the difference in milliseconds between the mean time and the median time. So you can see up here, this was the mean and this is the median. So the difference, you just had to do 220 minus 150, and that's how they got the 70. Okay, question 2. Of these 800 times, the number of times that were longer than 300 milliseconds. So if you have a look, they've told me something to do with 300. If I go over here and look, 300 is the Q3. Okay, so how many times are longer or pretty much bigger than the Q3? If you think about, if you have a box plot and you've got your Q3, just remember anything above the Q3, is 25% of it is above it. Okay, so we pretty much have to say 25% of 800, and we'll find that, and that obviously equals, so if you're working that on your calculator, you can just 0.25 times 800, and we get 200. Okay, with question 3, the shape of the distribution is best described. So we have not been given a graph, but we could roughly sketch a graph. So if you look here, we've got the median. So we said the median's at 150. And then they're saying Q1, so this was median. If we go Q1 is, I'll just say, is at 70. So in here was about 80. There's an 80 difference, isn't there, between 70 and 150. If you look at Q3's up at 300. So there's actually 150 difference in there. So if I have this shape like this with a box plot with a small bit at the start and a larger bit at the end, we know that is positive skewed. Okay, positive skewed. So we know that for a fact. Now, but we look down, so we could get rid of this, the negatives, okay? But now we have the 2 and 1 with 1 or more outliers. So what we want to do is we can see this maximum values and the minimum values. So what we could do is find the upper and lower fence, and if there's an outlier, that maximum or minimum will be an outlier. So we will find the upper fence, or the lower fence. So the lower fence equals Q1 minus 1.5 times the interquartile range. So if you were doing that, we've got Q1 in the table there, 70 minus 1.5 times, and it's, 300 minus 70. So you get an answer for that. You get negative 275. So there's no lower fence, because the minimum value is 10, so that's fine. But if we look at the upper fence and we go Q3 plus 1.5 times the interquartile range, so it'll be 300 plus 1.5 times the 300 minus 70. If we do that, we get a fence. So we get 645. So any number above 645 is an outlier. So we can see the maximum value is already above that. So that becomes an outlier. So we know that. So this is how we're going to pick the positive skewed with an outlier. Okay, so let's question 4. The histogram below shows the distribution of the forearm circumference in centimetres of 252 men. So when you're going through this, maybe start highlighting, and I like to write n equals 252 just so I know, but they've done it there, so that's all right. Now the third quartile for this distribution. So you need to know, this is a skill that's listed in your VCART things, that you need to know how to get from a histogram, you need to be able to work out the median and obviously the Q1 and the Q3. So it's pretty much very similar. When we find the median, we know that it's the middle way mark of all the data. So if I've got 252 in total, if I was finding the halfway mark, half of 252 is 126. So there'd be 126 below that and 126 above the median. Now you can find the Q3 is pretty much like the median of the top half. So if I split 126 in half, I'd have 63 below it and 63 above it. So that tells me I want to start, because I want to find Q3, I can go from the end and I want to go in and find the 63rd frequency, like the spot. So what you're going to do is you're going to add up these frequencies. So to me, this looks like a 6, and then we had, say, a 3. Yeah, so at the moment, so 3 and 6 is 9. Then I add a 10 and a 10, so I'm up to 29 at the moment. Then I add, say, roughly a 15, so I'm on to 44. And then I add, what was this last one? Is about 20. It's about 22. So I'm definitely in this column here hitting that 63rd mark. So, oh, sorry, I went a bit too far, didn't I? Sorry. In this one, yeah? In this one, we're hitting the 63rd one. So if you look at that, that's between the 30 and the 30.5. So which answer is the only one between those values? And it is C, okay? Okay, so in the table 2 was collected in a study of the association between the variables frequencies of nightmares, low and high, and snores, yes or no. Okay, the variables in the study, frequencies of nightmares, low, high, and snores, no, yes, are, so because you have the frequency, this is still categorical, isn't it? It's a categorical, but if you're in low, I know you have lower nightmares than the high people. So that one is definitely ordinal. And this one, yes, no to snoring, there's no ranking there. So it's still categorical, but it is nominal. So because they've listed it that way, categorical first, ordinal first, then nominal, that's why the answer A is, when they say the word respectively, it means whichever they mention first in the question is mentioned first in the answer, okay? Okay, the next question, 11, it says the percentage of participants who study who did not snore is closest to. So all the participants, so we've got 161, so we've got the total. So when you're working out a percentage, remember we want the amount over the total. So they said of the participants in the study, so that means the total was 161, and they said who did not snore. So snores, did not snore, so that would be all these people do not snore, so that would be 91 times 100. And you get 56. Is that okay? Question 12. Of those people in the study who did snore, so this they're only talking about the snorers, the percentage who have a high frequency of nightmares. So we want a percentage again, so it's the amount out of the total. So the total will always be generally mentioned as of these. So because it was of the snorers, so we had 70 snorers, and it says the percentage who had high nightmares. So of the snorers, there was 12. The body mass index in kilograms per square meter was recorded for a sample of 32 men and displayed in an ordered stem and leaf plot. Okay, just going to go over a stem and leaf plot because it's in your sack. When you draw a stem and leaf plot, you have to indicate a key. That is a point will be allocated to that. And then allocation will be given that you've done the right, you put the stem in, and that these numbers are in lowest to highest, yeah? So that's what they're looking for. But the key is very important, and in an exam, I would like you to go high. When you get a stem and leaf, go look at the key and circle it so that you're jerrying what it is. Because this one, it actually is a decimal place, the leaf, okay? Just so that you're aware of that. So the shape of this distribution is described. So remember, with the stem and leaf, if I grab it and I turn it around like this, remember now you can see that it's mainly up the front and going down like that. So we're going to say that it's positive skewed. We probably could say positive skewed with no apparent outliers, just so we cover ourselves in case there is or something and we haven't worked it out yet. So with no apparent outliers. Okay, with the next one, it said determine the median BMI for this group. So if you look up here, we've got N is 32. So if you've got 32 data, the median's going to happen between the you'd have 16 and 16. So between the 16th and 17th data entry. So you've got to count up in order. So I'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so it's in between these two, which is 24.5 and 24.6. So what number happens in between them is 24.55. Okay, people with a BMI of 25 or over are considered to be overweight. What percentage of these men are considered to be overweight? So of these men, so once again, when you're working out a percentage, do percentage equals an amount over total. So they've said of these men, so I've got 32 men, okay? They told me up here. And then they're saying if you're over 25 BMI, you are obese. So I have to count the over 25s. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 that are overweight, considered obese. And we times it and you get 37. The next size in centimetres of 250 men were recorded and displayed in a dot plot below. So here they're telling me there's 250 men. Okay, the first question, write down the modal next size in centimetres of the 250 men. So the modal is the most common or frequent, and I can see here this tower is the biggest, so that is the mode. So 38 centimetres. Okay, it says now down here, assume the sample of 250 men has been drawn at a random from populations whose next size were normally distributed. So now they're telling me that we're doing that bell-shaped thing. So we've got a mean of 38 and a standard deviation of 2.3. So what you've got now, if we do this bell shape, this is what we're talking. As soon as they say normally distributed, we're probably going to be dealing with this bell shape, and we're going to have like the 1 standard, 2 and 3, minus 1, 2 and 3. And we'll just go on to the question first. It says, how many of these 250 men are expected to have a next size that is more than 3 standard deviations above or below the mean? So they just want how many of these are expected. So because they've said it's normally distributed, we would just be using, because they're just saying what is expected, we're just using the percentages. So do you remember in here, when you've plus or minus 3 standard deviations, you have 99.7%. And these little tails here are 0.15% and each. So they go how much of them are just above. So if I add those two tails together, I have 0.3% are plus or minus 3 standard deviations. So I want 0.3% of the 250. So if you change, make sure 0.3% is actually 0.3 over 100 times 250. So that will be 0.003. Just be careful with that. So if you end up doing that on your calculator, you get 0.75. But they've said round, and this is where we're going to be important, nearest whole number. So 0.75 to the nearest whole number is 1. So I've got 1. Now it says how many of these 250 men are actually have a neck size 3 plus or minus 3 standard deviations. So that's where you have to work it out. So the standard deviation is 2.3. So if I do 38 add 2.3, it'd be 40.3. If I add another 2.3, it'd be 42.6, and another 2.3, it'll be 44.9. Okay, anything above 44.9 would be would be above that. So is there any above 44.9 up here? No. But what about if we go below? If you go 38 minus 2.3, you get 35.7 minus another 2.3, you get 30, what am I saying? 33.4, and another 2.3 would be 31.1. Now, anything lower than 31.1, is there one lower than that? Yes. See that little guy there? He is lower. So there's how I got, there's actually one lower. So the 5-number summary for the sample neck sizes in centimetres is given below. So use the 5-number summary to construct the box plot showing any outliers if appropriate on the grid. So this is part C of that question before, and they did say you can use all the data. So you, even though they've given you the 5-number summary here, there are pieces of information missing for us to know. So first of all, we need to know if we are to know if there is an outlier, we need to know the upper and lower fence. So let's go and find the upper fence. So the upper fence is Q3 plus 1.5 times the IQR. So in this case, it'll be 39 plus 1.5 times 39 minus 36, which will equal, okay, we get 43.5 is our upper fence, and we need to know our lower fence, which will be Q1 minus 1.5 times the IQR, which is 36 minus 1.5 times 3, which is, what's that? 30. So 31.5 is our lower. So looking up here, the minimum value up here, that's not an outlier, is it? Oh, it is actually. It's lower. So 31 is going to be an outlier. And so is 44 because it's larger. This is going to be an outlier. But what we need to do is you need to go and check that dot plot and make sure there's not any other dots or data values lower than that. So I'll just go grab. Okay, so I'm looking at this dot plot here, and I know anything above 43.5 is a outlier. So I can see there's one here, just one, and then the next value is 43. So when you're doing this, your dot plot, you're going to have your outlier at 44, but then your next line, your next point is at 43. So this is where your whisker is going to go to. Your whiskers are important. Your whisker goes to the highest value, except if it's an outlier, it becomes a dot. Okay, so then if I look down the other side, we've only got one outlier at 31 because that's the only one under. So I would draw, here comes an outlier at 31. Now my next value is at 32. So my whisker will go to 32. Now if I go and put in all the other things, so Q1 is 36. So I've got a line there. Median is 38. Q3 is 39. And there we go. So I draw that up like that. Use a ruler. Try to be neat, and then we draw the whiskers have to go to those, and then you get your 2 dots. In a study of the association between BMI and neck size, 250 men were grouped by neck size, below average, average, and above average, and their BMI is recorded. 5 number summaries describing the BMI of each group are displayed below. Okay, and blah, blah, blah. Okay, what percentage of these 250 men are classified as having a below average neck? So if you go look, so we're looking for below average neck, below average, and here there was 50. So we're percentage, remember, so when we're saying percentage equals amount over total times 100. So they've said of these 250 men, so that was easy, they told me the total, how many have a below average neck? So you go 50 times 100 and that you get 20%. Okay, everyone get that one? Okay, what is the interquartile range of the BMI for the men with average neck size? So we're looking for average neck size. So this is the interquartile. So go up here, average. Interquartile is 26 minus 23.4. So there you go. So IQR equals Q3 minus Q1. You just had to read the data correctly. 26 minus 23.4 equals 2.6. People with a BMI of 30 or more are classified as being obese. Using this criterion, how many of these 250 men are classified as being obese? So we need to be looking at this box. All right, if we look at this box plot, we can see we're looking for the number, we're looking for 30, like the 30 number. So you can see that is along here. So here's the 30, so the 30 line. So any above that are obese. So we want to know how many of them are there. So if you look at it, this Q3 is on 30. So anything above Q3 is 25%. Yeah, there's 25% of the data. So what we're going to say, 25% of that 76 are above 30. And if you look here, this one here, its whisker stops at 30, and then it has 4 outliers. So there's 4 here that are above 30. So that's how we're going to do it. So we're going to say how we calculated. We went 25% of the 76 plus the 4. So you can just go 0.25 times the 76 plus 4, and you'll get 20. It says rounded to 1 decimal place. So, okay, it said 1 decimal place. I actually should have 0.0 there. Okay, so 23.0. So there was a lot missed out on those things in the SAC as well. So make sure you do that. With this last one, do the box plots support the contention that BMI is associated with neck size? So remember what I said. If there is a change equals an association. So if it goes like increases, decreases, if they change, we're going to say they're associated. If they stay the same, if they're the same, equals no association. That's the easiest way to remember. So this thing, if you look, it was 2 marks. So first of all, you're going to get a mark for saying, yes, it's associated because there's an increase in median. So can we see how the median is going up as the neck size goes up. Yeah? So I'm going to say yes. And the next mark is for the stat. You have to give the statistics. So all you do is just go, yes, as the median neck size goes up, median BMI goes up with neck size, with the below average neck size at 21.6, the average neck size 24.6, and the above average 28.1. Just don't, you are looking for the stat and the response of changing. So